Hello, students. This is Pallav sir, and I welcome you all again to my class. And today we'll continue with chapter number one, number system. And today's topic is, as you see on the screen, how to find more than one rational number between two given rational number. So, let me just give you some examples by which this topic would be crystal clear. Now, the first example, find five rational number. Find five rational number between 3 by 5 and 4 by 5. Now, as you see, these are the two given rational number, and both the rational number are having the same denominator. Now, in this case, how exactly you will find five rational number? Very easy, students. So when you see the given rational number having the same denominator, students, so the first step that you will do is you have to multiply both the numerator and the denominator with some number, with one number. So what is that number? So now in the question, what is given? Five rational number. So if five rational number is given, then you multiply both the given rational number, that is with the numerator and the denominator, with 6. If four rational number is given, then you will multiply by 5. If 7 rational number is given, then you will multiply by 8. Understood? Very simple logic. So 3 6 are 18 and 5 6 are 30. The same thing you will do with the another rational number. Again you multiply with 6 with both the numerator and the denominator. So in this case you will get 24 and 30. Now in between 18 by 30 and 24 by 30 you have to write five rational number. So how to write it down? So you will write this two rational number first, 18 by 30 and 24 by 30. Fine. Now you have to write five, any five rational number. So 19 by 30, 20 by 30, 21 by 30, 22 by 30 and 23 by 30. These are the five rational number between 18 and 30 and 24 by 30. So you will highlight this five rational number like this. So this is the given answer, students. Very easy. Now what if I give you another question and show you some other variations? Now see, what if I give you find again five rational number between 3 and 4. Find five rational number between 3 and 4. So in this case you do not see any denominator is there, but as I said, denominator does exist, but we don't write that denominator, that is 1. So we'll write the numbers along with the denominators. Now again we see that both the rational numbers are having same denominator, isn't it? So what we have done in the previous case, if we have the same denominator, so we'll multiply with what number? If five rational number they have asked, then we'll multiply with the succeeding number. That is, what is the succeeding number to 5 dash 5? That is 6. So in this case again five rational number. So what we'll do? We'll multiply each rational number with 6 with both the numerator and the denominator. So you see, we'll get 18 by 6. Same thing we'll do with the another rational number, that is, you will multiply 6 with both the numerator and the denominator. So you'll get 24 by 6. You see, Now again we'll write 5 rational number, that is 18 by 6. Here you will write 24 by 6. So we'll write 5 rational number now, 19 by 6, 20 by 6, 21 by 6, 22 by 6, 23 by 6. These are the 5 rational numbers. So we'll highlight this like this. So this is how we'll answer this type of question. Now let's come to the next part of the example. So this is the last part. So what if I say insert, again I'm asking 5 rational number between suppose 3 by 5 and 2 by 3. Now you see both the rational numbers are having different denominators, students. Now this is very important question, but at the same time very easy. Fine. So in this type of sum, you see these are the required given rational number. So in between this two rational number, you have to insert 5 rational number. So before that, you need to make the denominator similar. For that, what you have to do? You have to find out the LCM of the denominators, that is 5 and 3. So if you do the LCM of 5 and 3, you will get 15. Fine. Now, individually, you will write the rational number. Now, this is the first rational number, so I have written 3 by 5. I have given in multiplication sign. Now, our first objective is to make the denominator similar. How to do that? Now, this is the required LCM, isn't it? 15. Now, this 15 you will divide by this denominator. So, when you divide 15 by 5, what is the answer? Obviously, very true. It is 3. So, you will multiply this 3 with the numerator and the denominator as well. So, you see what is the answer you will get? 9 upon 15. Same thing you will do with the next rational number as well. 2 by 3. Now, you have to divide this 15 with this denominator. So, when you divide this 15 with this denominator, that is 3, you will get the answer as 5. Now, this 5 you will multiply with the numerator and with the denominator as well. So, you will get the required answer as 10 upon 15. Fine. So, this is the first step. Now, you see the denominators are same. Now, what we have done in the previous case, if the denominators are same, then we are supposed to multiply again, but just by saying how many rational number we have to prove. If they have asked 5, then we'll multiply by 6. If they have asked 7, then we'll multiply by 8. So the same logic will use it here as well. So the next part is, you will write 9 by 15. How many rational numbers we have to insert? 5. So we'll definitely multiply by 6. So 6 9s are 54 and 15 6 are 90. Absolutely. Now write the next rational number, that is 10 by 15. Again we'll do the same thing. We'll multiply 6 with the numerator and with the denominator. So the required answer is 60 by 90. Fine. Now we'll insert 5 rational number between 54 by 90 and 60 by 90. So what are the required rational number? 55. Just a minute. 55 by 90, 56 upon 90, 57 upon 90, 58 upon 90 and 59 upon 90. So these are the required rational number. Fine. So as you see, this will carry 2 marks. Very important question. Fine. So these are the types of how you insert more than one rational number between the two given rational number. So now let's move on to the last topic of today's session. So today's last topic is decimal representation of rational number. So now how to do this? What is the meaning of this? Again, I will explain this topic with the help of example. Now, what I'm trying to say is that suppose if any rational number is given, suppose 1 by 4, fine. Now you have to represent this rational number in the form of decimal. But you have to understand one thing, student, that every rational number, when you divide, it is not every time that you will get 0 as a remainder. When you get 0 as a remainder at some point of the division, that means that decimal will be called as a terminating decimal. But when you see that you're not getting 0 as a remainder, fine. So that particular fraction or rational number, not fraction but a rational number, will be called a non-terminating decimal. So when we talk about decimal representation of a rational number, so we'll first try to see what is a terminating and non-terminating. Just let me write this first. So these are the two topics that we'll cover, that is terminating decimal and the next one we'll try to understand, that is non-terminating decimal. Okay, now in our next class we'll learn repeating and non-repeating. Fine. So let me just give you one example of terminating decimal. So example for this. So example. Now what if I divide 1 by 4? Fine. So let me divide then 1. Now as you see, 1 is not divisible, so definitely we'll take decimal here and we'll insert 1 0. Fine. Then 4 2s are 8. Again, because of this decimal we can put 0 here, so 4 5s are 20, isn't it? So as you see, we are getting remainder as 0. So what is the answer? Answer is 0.25. So this is called terminating decimal. Let me just give you another example, that is 5 upon 8. Now what if I divide 5 by 8? So again, this is smaller number, so again we'll take decimal here, we'll put 0. So 8 6 are 48. The difference would be 2. Now because of this decimal we can again take 0 here, so 8 2s are 16. Again 4. Because of this decimal we can again put 0 here, 8 5s are 40. Now you see, again we get 0. So this type of decimal, so answer is what? Answer is 0.625. So this type of rational number, where after dividing if we get 0, so this type of decimals is called terminating decimal. Now let me give one example of non-terminating decimal. Now non-terminating decimal. Yes. Now let me show you some example of non-terminating decimal students. Fine. Now you see, if we divide 15 by 7, what will happen? Just see. Now 7 2s are 14, isn't it? You'll get 1. Now we'll take decimal here, we'll put 0 1 here, so 7 1s are 7. Now you see 3. Again for this decimal we can take 0 here, 7 7 7 4s are 28, isn't it? 28. Now this time we'll get 2. Again for this decimal we again put 0, 7 2s are 14, because 7 3s are 21, 7 2s are 40. Now we'll get 6. Again for this decimal, we'll again put 0 here. 7 sevens are 49, 7 eights are 56. Yes, 7 eights are 56. Now again you will get 4. For again this decimal, we'll again put 1 0. So 7 5s are 7 sevens are 49, 7 6 are 42, 7 5s are 35. Let me write it down. 7 5s are 35. Now I will get 5. As you see, this type of division, you will never get 0. It will keep on going and keep on going. It's endless, students, endless. So it will just go on and on and on. Fine. So now this type of decimal is termed as non-terminating decimal, where you never get 0 as a remainder. Fine. So I hope you have understood today's lecture. So go through the video very properly, and I hope that you have all understood whatever I've explained today. So till we meet next time, so take care of everyone. God bless you all, and be safe.